Hi, this is Barrett Gibbons. In this video, I'm going to review the basics of complements of sets, and at the end, we'll talk about DeMorgan's laws for complements, unions, and intersections. All right, so what is the complement of a set? Given a set A, the complement of A is the set of all points in the universe, which I'll say X, which are not in A. So as a Venn diagram, I have my universe X and my set A, and the complement is all of the things that are outside. Complement is all the stuff that's outside here. Okay, so that's the complement. And there's a lot of different notations for it. Sometimes it's written as A with a bar over it. Sometimes it's written as A with a capital C exponent. Sometimes it's written as X minus A. And sometimes it's written as this X, and there's this kind of like diagonal minus sign. They call it set minus. Okay, so these are some of the notations that I've seen. There's probably more notations. So one thing that you want to be really careful about with complements is that the universe X really matters. And so let's see some examples of that. Consider the set A equals the natural numbers. What is in complement A as a subset of Z? So if I look at all integers, and then I think of my subset as the natural numbers, then the complement would be integers which are not natural numbers. And so that would be all of the negative integers along with 0. Okay. What about as a subset of the reals? As a subset of the reals, then that would be all of the real numbers up to 1. So I can write that in interval notation, negative infinity, comma 1. And then all of the real numbers between 1 and 2, all of the real numbers between 2 and 3, and so on and so on and so on. So like on a number line, what would it look like? I'd have an open circle at 1, an open circle at 2, an open circle at 3, open circle at 4, and so on. And I would be shading, the complement would be all the stuff that's outside of those open circles. What if I think of it as a subset of n? So if my universe is natural numbers, and then I want to know what are all the points that are not natural numbers, well, then I've taken everything away. There's nothing left. And so that would be the empty set. Okay. So what you think of as the complement really depends on both the set and the universe that you are under. And oftentimes the universe part might get kind of skipped when you're explaining it, because a lot of times we have an assumption, like maybe if you're in a real analysis class, the universe is almost always the real number line. But if you're in a number theory class, the universe is almost always all integers. And so oftentimes we have sort of an assumption about what our universe is. Okay. So now let's just talk about DeMorgan's laws a little bit. So DeMorgan's laws let's just think about them first for two sets. So let's let A and B be two sets in a universe X. Okay. And then to help us kind of figure out what's going on, let's shade A complement. So A complement is the stuff outside of A. I'm going to make that a little bit bigger so this goes slightly faster. A complement is the stuff that's outside of A. And then B complement is the stuff that's outside of B. And I really should have labeled A and B here. So this is A and this is B. Okay. And so A complement and B complement, let me shade those. So A complement is the sort of peach stuff and B complement is the sort of blue stuff. So what is A complement union B complement? So A complement union B complement would be anything that's shaded in either color, anything that's shaded in either color. So it's everything but the plain white part. That means it's everything but the part where they overlap. And so that means that it's the complement of their overlap. So A complement union B complement is A intersect B complement. Okay. And then similarly, A complement intersect B complement. A complement intersect B complement, that's the stuff that is in both complements. So it's the stuff that got shaded both blue and peach. And so it's the stuff that's kind of grungy color, kind of that yucky blue and peach mixed color. So that's the stuff that's like outside both of them. But another way to say that is that's the stuff that's outside of their union. And so this is A union B complement. Okay. I might also write this as X minus A complement union X minus B complement is equal to, sorry, I wrote that completely wrong. X minus A, I'm using the X minus A instead of the complement notation. X minus A union X minus B is equal to X minus A intersect B. And X minus A intersect X minus B is X minus A union B. Okay, so these are called DeMorgan's laws. These are called DeMorgan's laws for two sets. And I can generalize this to when I have any number of sets, it's the same sort of thing. So when I have any number of sets, if I have a union of A sub alpha and I want to take the complement of that, that is the intersection of A sub alpha complement. And if I have the intersection of A sub alpha complement, that's the union of A sub alpha complement. Or using the notation that uses universes a little bit more clearly, X minus the union of A sub alpha is equal to the intersection of X minus A sub alpha. And X minus the intersection of A sub alpha is equal to the union of X minus A sub alpha. So just two different ways to write the same thing. And finally, we can sort of think about this in terms of logic. Like, what would it mean to say that X is an element of the union of A alpha complement? So using order of operations, overall, this means X is not in the union of A alpha. To be in the union, you only have to be in one set. So this says that X is not even in one set. So X is not in A alpha for any alpha, because if it was in even one of them, it would be in the union. So if it's not in A alpha for any of the alphas, then that means X is in A alpha complement for all alpha. And if it's in A alpha complement for all alpha, then that's the definition of intersection. So that's another way that you can think about it. If you don't like the Venn diagram method, then this right here, this is basically the proof of that first line. Okay? All right. So thank you so much for listening.